Hi, I'm Bob Lieberman, and next year I have the honor of being president of SPIE, which is the International Society for Optics and Photonics. You might ask, what does optics and photonics mean? Well, optics is the study of light and how light interacts with matter, and photonics is the technology that comes from the study of light. So optics and photonics together are the science and technology of light. And this is a particularly important year because 2015 has been declared by the United Nations to be the International Year of Light and Light-Based Technologies, the International Year for Optics and Photonics. So our society, which has 25,000 members around the world and 150,000 people who attend our conferences and read our publications, we're really, really proud to have our field recognized by UN and UNESCO this year. And part of my job as the incoming president of SPIE is to help popularize and educate the world about our science and to make connections between the scientists and technologists that are working in this field. In particular, one of the most important things we do is make connections with people in other countries. Although the headquarters of SPIE, well, SPIE actually has headquarters both in Europe and the US, but although our main headquarters are in Europe and the US, we hold conferences and have members around the world, including, very importantly, people here in Brazil. And we actually have a student chapter of our organization that has done remarkable things in helping to educate the public here. I've been visiting now in São Carlos for about a day and a half, and I've just seen magnificent optical science being done. Everything from very fundamental basic physics being studied using light, all the way up to products that can help make people well, to help move society forward, being developed and actually created by the scientists and engineers who work here in São Carlos. I've been really very impressed with my visit here. It's just magnificent what goes on. There are marvelous people from the undergraduates all the way up to the graduate faculty and the professors who work here in this field. I think that one of the more interesting things that I have found out is how much is actually going on in the country of Brazil in this field. There are hundreds of people working in optics and photonics, many of them educated within Brazil, but also from around the world. Researchers have come and work here in São Carlos and other universities on a wide variety of technologies, everything from making photocells better for creating electricity, to using light to diagnose medical conditions and using light to detect and monitor everything from pollution to the health of buildings and structures. So I really, really believe that Brazil is at the forefront of some of the areas of optical and photonic technology research. So it's been exciting for me to come here. It's only my second time in Brazil. I'm sure it won't be my last time, and I definitely plan to come back. But I'd like to broaden the scope maybe a little bit further beyond Brazil, beyond São Carlos, and talk about the impact of light and light-based technologies on the world, on society today. I think maybe people take for granted the optical technology that is making it possible for me to talk to you right now. Face it, you're looking at me on an optical device. The screen you're looking at as you're hearing me speak is actually photonic technology. There are photons, there's light being emitted by this device, and your eyes are looking at it. So that's photonic technology right there. Furthermore, you could not make that screen without another level of photonic technology. The actual screen itself was fabricated using light. The computer chips that create the signals that are presented to the screen have been made using light, using incredibly sophisticated machines that project large-scale images of the chips down to tiny, tiny, tiny shapes on silicon. The fabrication of silicon chips, of electronic chips, is all done with light. This signal, once it's generated at the television station, comes to you on an optical fiber. Okay, on a cable, the last few meters of signal come through electronics, but all the way to probably the curb of your block, the corner of your block, it's carried by an optical fiber. So optical technology is fundamental to the communication of information. And it's really amazing. It's everywhere. Optics is everywhere. That's just one example. You look at your cell phone. Again, the cell phone is all made with optical technology. The screen is optics. It has a really good camera in it. That's optic and photonic technology. So going on into other applications, into the medical field, for example. The microscope, the most fundamental diagnostic tool for checking whether or not you're sick, the microscope is optical technology. Optical fibers are used to see inside the human body without cutting it open. Optics is now being used. I mean, there are lasers being used as scalpels. Laser-based technology is revolutionizing medicine. Photons, and in fact, some of the most important work being done right here in São Carlos uses light to cure disease just by shining the right color of light on diseased tissue. You can cure many diseases. Cancer is being cured using photodynamic therapy, using photons, that is light particles, to activate drugs that can eliminate cancer cells. It's just remarkable what is being done in our field. The scale of things that are addressed by our field around the world is truly enormous. From the tiniest things you can think of. Individual little tiny atoms now can be seen using revolutionary optical technology. You can actually see images of single atoms, single molecules moving around within living cells using advanced optical techniques. On the other end of the scale, not too far from here, in the Cerro Torolo, there are telescopes that can see to the edge of the universe. It's really, really remarkable, the scale and breadth and impact that our science of optics and photonics has on the world. And SPIE is engaged in making connections between the scientists that actually do this work. It's engaged in helping to foster new research in this area. It's engaged in bringing students together with the general public to educate them, as I'm doing now, on the importance and possibilities of what can be done with our field. So I think that in closing, one of the most important things that I would like to leave with you is just an appreciation for how impactful the science and technology of light has been. And as just one little tiny example, I'd like to talk about some work that I saw done here. I've been visiting a number of laboratories. Really world-class science is going on here at this university. I've been visiting a number of the laboratories in the Optics and Photonics group here, and what I've seen has been remarkable. Just one tiny little example. I was in a lab that does biophotonics. That's a wonderful word, biophotonics. The science of light applied to biology and medicine. And in this lab, I saw research going on in a lab bench that allows people to see whether or not tissue is well, whether or not skin or bone or teeth or internal organs are sick or diseased or suffering from cancer, or whether or not a particular type of tissue is cancer or normal tissue. This is very important, fundamental research, but more exciting. In the same lab, actually in the lab next door, I saw a machine that uses this same knowledge to actually diagnose cancer in living people. So one of the most impressive things that I've seen here at this institute is the ability to go from very, very deep fundamental studies of science all the way to products in the real world that can help people live better and more healthily. So I'm really happy that I was invited to come here. I've had a wonderful time, and I'm looking forward to coming back again. Thank you very much.